we had 20 people with sex A and age A, and an associated age, and 30 people with this other sex and other age, we create the instances of the same dynamic event. And that dynamic event would remember the sex and age with which to create them, and it will go off on their birthday sometime during the year. Okay, so here we define the dynamic events at design time. We tell them what parameters, what information they need to remember to do their job. And then when we create them, they're given that information they need, and then sometime off in the future, as we specified, they'll do their job. Okay? So how do we set a dynamic event? Well, what we do is from the palette we drag this thing called dynamic event, and you'll notice that for the dynamic event, there's a set of parameters to be specified down here. So we'll specify for this dynamic event, hey, you have to create an instance of this dynamic event. To create an event to be scheduled of this sort, you have to provide these parameters. So an example of this would be, suppose we had deers in our model, in the chronic wasting disease model, and the deers mate at some point. And we want to schedule the birth of the fawn that will result from that mating some point in the future. So the deers are going to mate, and the characteristics of the fawn will be known. We'll decide what the characteristics of the fawn are at that time. A fawn is a baby deer, for those not familiar with that. So suppose there's these two deer that meet up, a male and a female deer during rut, during the fall, and they conceive of a fawn, and that fawn won't be born till the spring. But we know at the time of the mating, we'll decide, okay, what's the genotype of the fawn going to be? What is its mother and father? What is whether it's going to have a certain disease passed on through the mother, etc. These characteristics. So we'll create this dynamic event, and we'll pre-schedule that birth of the fawn for 6 months from now. And so the birth of the fawn will be scheduled, and we'd have parameters which specify what the characteristics of that fawn will be. And then when the fawn is to be born in the spring, the action will be undertaken, and that action will depend on these parameters typically. In this case, it might be add a baby into the model, a baby deer into the model with these characteristics. And boom, it will get added to the model, just like that. And the baby would remember who its mother and father are and all those sort of things. And the event that went to create it would disappear. Okay? So here's an example of this. Here's scheduled deer birth, and the parameters here are whether the deer to be born is female, what's the genotype, what's the latitude and longitude at which it was conceived, or whatever other information. And then there'll be an action which adds that fawn to the population. What I want to emphasize here, folks, and this is really important, is that this information, these parameters to be specified, are provided when the dynamic event gets created. The instance of this dynamic event gets created. That's when these parameters are specified. And that instance will sit around for however long that baby deer is in gestation, however long the mother is pregnant, until sometime later, sometime in the spring, it'll come time for the baby to be born, the fawn to be born. And at that point, the action will be executed. So it's remembered all this information. Those of you from computer science background may have encountered the notion of a closure before. How many people have heard of a closure here? Okay. Oh, my heart goes out to you folks. Closures are one of the most beautiful things you can see. You should go learn about them. Maybe I should have a tutorial on closures. But a closure is basically a pairing of an environment on the one hand and a method or function, depending on your language, on the other. It pairs some information, some context with a job to be performed, with an action to be performed. And that action will typically make use of the information in the closure. So by creating these closures, we can remember the requisite information, and we can then perform the action required. So we might create a closure, for example, which we might take an add function, which adds two arbitrary numbers, and we close it with information about what its first argument will be. We curry it. And so then if we do this with the number 1 as the initial argument, then now we'll have created an increment function, something that adds 1 to everything that's provided to it. We've created that information in a closure. It has all the information it needs to do its job later. So here, we've created a sort of closure of sorts. We've created this dynamic event that's just waiting to happen. It has all the information it needs, provided when it's created to do its job. Finally, in the spring, when the sun is shining and it's warming up and the winter has passed, the baby will be born, he'll be added to the population, and the dynamic event will disappear. It will disappear. Yes, Dylan. Yep. Okay, so it's a good question. Let's I'm going to just try dragging one of these in into my model here, and I think I will see if I could switch Neil over to AnyLogic to see this. So the deal is, when you add one of these to your model, what you're going to do is to specify when it gets scheduled for, how far from now it's scheduled for. Okay. So I think I have an example of this. Let me just see if I have a pre-canned example. Looks like I don't. What I will do is see if I can drag one in here. Okay, so there's my dynamic event, and this could be scheduled dear birth, and this provides the various sorts of information about it. But the answer is, I'm going to show here in the AnyLogic help for this what the syntax is, because it's not going to provide me with the exact syntax. But dynamic event here, and okay, this is the detailed information on it. Okay, so this is the syntax you use, Dylan. You'll see this create underbar my dynamic event. So if we have to schedule dear birth, and perhaps we want, this is in main, so maybe in the startup code, we would do create schedule, create underbar schedule dear birth, and we could compile it now. Okay, so method, okay, yes, it needs a time from now. This specifies the number of time units from now that we want that event to go off. Okay, so this schedule dear birth needs to provide all the requisite information to do its job. And the key piece of information that you're asking about is the timeout, but then there's a set of parameters that must be provided. Okay? So in other words, when I create this event using create underbar the name of the dynamic event, I tell it when should it be scheduled, some amount of time from now, and I tell it all the information it needs to do its job, to be packed away in those parameters. Namely, in this case, it's this information. This information is specified by the parameters, which in this case happens to be, I didn't put anything in, but I could put is female, and make it Boolean, right? And if I did this, now it's going to mean, hey, you got to provide, when you create an instance of this, you've got to tell it whether or not it's female. And I could do random true with 0.5 probability it's true, 0.5 probability it's false. So at this point, when the model starts up, it's going to schedule a deer birth within the model. So there's going to be a birth scheduled 0.5 days from now with this characteristic, this parameter. So this random true thing here is providing the parameter that's required for this to be created. And once created, that thing will just be waiting to go off at the specified time. Does that make sense? Any other questions about this? Dynamic events. It's notable that I could create 100 of these. So folks, I mean, just drawing on this, in this main here, in the startup code, I could create, 100 different deer to be born, and I could create them to be scattered through the next year from, over a 365-day period. They're going to be scattered through the year. There's going to be deer of random sexes scattered through the year. So here, there's going to be various deer born at various points in the year, 100 of them scattered through the year. And maybe when the deer is born, I will say, a deer has been born, has been born at time, okay? And so now if I run this model, I will have deer popping up, well, deer being told that they're born all throughout the model operation. So here we have the model running, and the infection is spreading, and you notice that here's the first two deer. The first two joyous events have occurred here. And then here's two more, for example. They're just being scattered through the timing of the year in a random fashion. So here we have deer whose births are being scheduled up front at the very beginning of the simulation, but their births aren't occurring until later in the simulation. But they have all the information they need to be born. So in short, they have their information on what sex they are, right? Here they know what sex they are. And in fact, I could say, this deer is a, and I think I said what, is female, is female. So if is female is true, it's going to say female. Otherwise, it's going to say male. Okay? So now if I run this again, what we should see is deer of various sexes. Various sexes being born here. Cannot convert to it from a string to a Boolean. Okay, let's see what's going on here. Okay, so is that going to, is there a precedence issue? Yes, good. Okay. So here we have these deer being born with characteristics that indicate whether or not they're female or male. So in this case, okay. So here we have a male deer being born at that time, and soon though there's a female born, and then two males are born shortly thereafter. They are being born with characteristics that were set when? When was the characteristic of this one being a female set, ladies and gentlemen? It was set at what time? When the event was created, which in this case was at the startup code for the model. It was associated with let me stop this. It was at the startup code for the whole model. So this is an example simultaneously handling an implicit event, starting up of the model. And we wrote a bit of code that goes through and adds 100 deer to be born at these times with characteristics set now, but to be realized in terms of an action, in this case just printing out a message, when it occurs. Does that make sense to people? Okay, questions on that? Dynamic events are an interesting concept to wrap your head around. I should emphasize that dynamic events is kind of a strange name for it, because the regular types of events are dynamic also. They occur over time. It's just that this is dynamic in the sense that it could turn into many instances at runtime. And in computer science, we often refer to that as sort of a dynamic quantity. It turns into many particular instances. Okay, so any questions about that? Okay, I'm going to go back now, and I'm going to see if I can bring back Neil to the PowerPoint here. Okay. Okay. Right, there we go. Oh. Okay. Okay, so we've seen how we can specify dynamic events, and we gave two instances of these things. One thing is to schedule a sort of a birth, at the time of conception. Another is the beginning of the year. Distribute immigrants, for example, through the year, or distribute births through the year. Okay. So if we have a known count of immigrants that we know have to come into the model for a given year from historic data, perhaps know in 1995 there were this many immigrants into Saskatoon. We don't know the dates in which they immigrated. We might distribute them. We might say, okay, the beginning of the year we'll distribute them randomly through the year, and then they'll get born at the appropriate times of the year. We'll set all the characteristics at the beginning of the year, and they'll simply get born through the year. Okay. So here we can add in an arbitrary number of events, schedule them at runtime. Okay, any questions about events before we go on to networks now? Okay, I'm going to go now on to the second phase, which is networks. And I'm going to stop this.